In lesson 3 here, we're going to look at 3 different ways to represent atoms. So some drawings, some different ways of kind of mapping them out. So basically, the first one we're going to look at, you've done before, is Bohr diagrams. I'll let you guys copy this here, but we're going to use the atomic number and the mass number to determine the number of each subatomic particle. We're going to place protons and neutrons in the nucleus and electrons in appropriate energy levels. We did this last year with Bohr / Bohr-Rutherford diagrams, yes? So I'll let you copy that. And then just kind of spread these out a bit. So if you can, like so, that'd be great. And we're going to do stuff underneath each one. Or if you just want to wait, you can do that too. It's up to you. Here we go. So Bohr diagrams, we've done these before, like I said, probably, but protons and neutrons in the nucleus, and then we're going to fill up the rings. We're going to fill them up in a specific order, and if you're in my class before, you know that I want them filled up in a specific order because that's going to help this year, okay? And if you're not doing this, well, I'll do it now, and if you're a little bit off, it's okay, but generally speaking, here we go. Now, we're going to do the same 4 examples for all of these diagrams. We have 3 different types of diagrams. We're going to do the same 4 examples, so the next one's going to have these same ones. Hydrogen's not the best one to start with, so if you're a little confused, just chill. Well, when we get to nitrogen, sulfur, I think it'll kind of explain it a little bit. So here's hydrogen. We're going to start with a symbol. We're going to start with the protons and neutrons in the nucleus. So hydrogen has, of course, 1 proton, yes. Doesn't have any neutrons according to the periodic table because it's got a weight of 1, yes? So that weight of 1 is that 1 proton. So you can put 0 neutrons if you really want to. You don't have to. I don't usually because I don't like to write extra stuff and it takes a lot of time. So that's the nucleus. Now sometimes students will put the electrons here kind of thing. I don't really like that, but if you do, I'm not going to mark it wrong. But I like to have like my first energy level here, by the way, that's kind of elliptical. Okay, it's not, and I put a dot. We use a dot to represent an electron. Okay, so 1 proton, and there's my 1 electron. Okay, is that good? Protons, neutrons in the nucleus, electrons there. Okay, we also have to remember how they fill up. So how many electrons can you have in the first energy level? 2. How many in the next one? 8. And next one? 8. And after that, we don't really do those. Okay, so just relax. It's okay. Nitrogen. It's a little chilly in here. I will try and fix that eventually here. I'm not sure why that's on. Nitrogen. What's the atomic number of nitrogen? 7. Yeah, just yell it out today. 7. What's the weight's 14.01? Yes. So that's another what? 7 neutrons, yeah? 7 jimmies. Toy Story, great movie. Okay, nucleus, yes. And of course, 7 protons, we need to have the same number of electrons, yes? So 7 electrons. So first energy level can have 2. We put those 2 together, okay? Or at least I do. Technically, just so you know, electrons have different spins to them. So one actually spins one way, like a clock, and the other one spins the other way. So they kind of cancel each other out. They have this unique ability to pair up, okay? And that's actually something called the Vesper theory, which sounds complicated, but we're going to explain that to you down the road here, okay? Electrons can pair up, and they start to repel other pairs of electrons, basically, is what that means. And that's going to help us predict shapes. So there's 2. How many more do we need? This is good old-fashioned math. 5, absolutely. So on this one, here's what's going to happen. We tend to break them up first. So we have a possibility of 8, and they can pair up. So there's 4 different what we call suborbitals here, okay? It gets a little more complex than this, but we're not going to learn that till probably university, okay? 1 goes here, 2, 3, 4, okay? So we're going to spread them out as far apart as possible. Then the 5th one, they have to start to pair up. Okay, there's only 4 places for these electrons to go. So now the 5th one comes along and it pairs up, for example, with this one. Now you might say, do I have to put it at the top? Can I put it on the side or somewhere else? Yeah, that's fine. Usually let's keep with this pattern here. It just helps us when we're drawing stuff. These are going to be called something when we start to bond, and it's nice to have those at the top or in specific spots, but it's not a big deal, okay? But that's what nitrogen would look like, all right? Let's look at sulfur. Let me go up here. Sulfur, 16 protons, 16 neutrons. That's where the 32.07 is, yes? Okay. So nucleus, we need to have 2. 1, 2. I like to pair them up there. Okay. Then that's 2. We need another. We need to get the 16, so we need another 8 here. These are all going to get filled up. And again, this is how they fill up. 1, 2, 3, 4. Okay. So they take positions as far apart as possible. Then they have this unique ability to spin the other direction, pair up. So there's 4, 5, 6, 7, 8. Okay. So there you go. Then that's a total of 10, 2 and 8, right? So we need another 6, yes? 6. So here we go, 1, 2, 3, 4. So I'm going to do exactly the same thing. And then I'm going to pair up 2 of those, okay? Now sometimes you want to make them all pretty. You think everything should look pretty, and you want to have, like, you know, if I'm going to put 2 electrons here, okay, then I should probably put the other one at the bottom. And I'm going to say, you know what, don't do that. Because I think that's going to lead us to some issues when we go to draw stuff. Just keep the same pattern going all the time, and it's okay, right? In the big scheme of things, remember, this isn't even legit, right? These electrons are motoring around the atom. We're trying to draw something that's static and stopped here. That's not even cool. Like, they're just going around and around. Some of them paired up, of course, and stuff like that, but we don't even know where they are, you know, for the most part. They're in a cloud, okay? So I'm going to put the last one right here, okay? So that should be 16, 2, 8, and then 6. Good? Questions, anyone? Just keep with that pattern. Good? Oh, I thought you were going to ask me a question. All right. Aluminum. Oh, crap. 13 protons, 14 neutrons, okay? 13 protons, 14 neutrons, 26.98, so 27. Okay. And then we're going to do 2. Uh-oh, I'm going to run out of room. Yep. There we go. Problem solved. I went to Smartboard school. Let's see, where are we here? 2, and then 8. 1, 2, 3, 4, 6, 7, 8, and then this one's going to have 3. And again, you might want to try and make them look pretty. You don't have to. Okay, just keep with the pattern. It'll be fine. Would they probably spread out a little bit more? Maybe, yeah, sure, but it doesn't matter. Okay, in the big scheme of things. Remember, we're just kind of trying to get a general idea what they look like. Okay, so those are Bohr diagrams. You remember those because they are boring. Look, rings. See, I don't know how else to explain this. Not everyone's laughing. I thought that was pretty. I thought that was money. Bohr, ring. It's rings. Getting mad. Okay, good. Questions? All right. So the next one, they're all kind of the same thing, but they're just kind of an adaptation kind of thing. I would say we use this is probably pretty good. We use what we call electron energy level diagrams sometimes. Okay, so you can just write down electron energy level diagrams. Write that down, electron energy level diagrams. I'll just pause it here for. So another way to represent atoms is what we call the electron energy level diagram. It's basically, if you kind of think about the last one, the Bohr diagram, if you started in the middle and kind of worked your way out from there, that's kind of what we're going to do here. So it's just another way to represent it. Again, hydrogen's probably not the best example to start with, but we will. Usually I start at the bottom and kind of work up. All right, so we start with a symbol, hydrogen. We're going to kind of use just levels, like lines, basically. Okay, so on the next part here, I'd have the nucleus. So this part would be the nucleus, 1 proton. And again, if you really wanted to put 0 neutrons, you could, I guess, but you don't have to. But that's where the nucleus comes. Okay, so symbol, nucleus, first energy level. Well, hydrogen only has 1 energy level. It only has 1 electron, so I'm just going to put that right here by itself. Okay, if it had another one, well, I'll show you the other examples, and then if you have any questions, ask. All right, is that okay? Symbol, nucleus, first, second, third, fourth energy levels kind of thing. So here's nitrogen. Nitrogen, 7 protons, 7 neutrons. Okay, nucleus. First energy level can have 2, yes? So 2, and then we need another 5 in the second energy level, okay, for a total of 7, of course. 7 positives, 7 negatives. Think about, the Bohr diagrams. Think about starting in the middle and just kind of going out from there, right? Sulfur is number 16, has a weight of 32, so another 16, just like before, okay? And then we can have 2 electrons in the first energy level, so those are those first two I drew in the first energy level. Then there was 8, and then there's another 6, okay? So first energy level, second energy level is filled as well, so then we got to go to the third energy level, okay? Good. And finally, aluminum. Again, I'll get out of your way right away here. Weight of 26.98. Okay, so 27. So 13, 14, and then we go to 2, 8, and then 3 more. Okay. Good. Any questions, anyone? Yep. Yep, sure. Okay, questions? Now, I'll pause it here for a second. Okay, so the last one we're going to look at, and this is by far the most important one, guaranteed, okay? We're going to use this like for the rest of like ever, is Lewis diagrams or electron dot diagrams, okay? A Lewis diagram includes the symbol of the atom and the correct number of valence electrons in the appropriate location. I only care about the symbol and the number of valence electrons. Valence electrons, of course, by definition, are the electrons in the outside energy level, yes? Okay, so we only care about those. We don't care about anything else. Protons and neutrons, don't care. Okay, they're just going to get in my way, basically, is what's going to happen. So, for example, hydrogen. Now, again, not the best first example, but hydrogen has 1 proton. We know it has 1 electron. That's all I care about, is that 1 electron. The electrons in the outside energy level, there is only 1 energy level for hydrogen. It's got 1 electron. So we're going to use a dot to represent that, and it's going to look a little something like that, hydrogen, okay? Now you might say, do I have to put the dot at the top? Can I move it around a little bit? You can. I will as well eventually when we match up some things for covalent bonding, sure. But for now, let's just kind of stick to that 12, 3, 6, 9 o'clock rock kind of thing going on. That's happy days. You guys don't know happy days, do you? Okay. Did we already talk about this? Joni loves Chachi. Joni loves Chachi. Dodgeball? No? Okay. Like I said, we're 6 years apart now. That's what happens. That wasn't a joke. You shouldn't have laughed at that one. Okay, nitrogen. Now, again, we only care about valence electrons. So, valence electrons, I'm pretty hip, right? We don't need to record this part, but okay. Yeah, we didn't need to record that. Nitrogen. Nitrogen. How many valence electrons does nitrogen have? That's what we're looking at, right? So, I'll skip back for this one here, but when we look at nitrogen here, here's nitrogen. Remember, valence electrons are only the electrons on the outside energy level, right? So we're looking at this particular energy level here. I don't care about the 2 there. Okay, I don't want to see those. We know that that's filled. I only want to know how many are in the outside one. How many do I have in the outside one? 5. So that's what I have to do here. Basically, you can look at this diagram and pretend to yourself, think of it this way. Get rid of the protons, get rid of the neutrons, get rid of the circles, put down the symbol, and just worry about the outside electrons. And they actually look like this, right? 1, 2, 3, 4, 5, right? So let's go back to here for a second, and I'm going to do the 12 o'clock, 3 o'clock, 6 o'clock rock, 9 o'clock rock, and there's 4, there's 5, yes, okay? That's a Lewis diagram. You have to be able to do these somewhat quickly down the road, because we're going to use this for making molecules and things like that. Sulfur. Sulfur has 6. By the way, in case you forget, how many do they have, or how are you able to do that so quickly? I'll tell you, because I've done this I'm 22, so it's been, what, a couple of years, 2 or so, we'll say. So I kind of remember stuff. But if you're like, how many valence electrons do I have here? Well, if you can count, you'll know. okay, for the most part. So look, where's sulfur? Well, sulfur is number 16. So what does that mean? 16 protons, 16 electrons. 2 go in the first energy level, right? Why do only 2 go in the first energy level? 1, 2. Yeah, there's only 2 atoms in the first energy level. Yes? That's where the 2 comes from. 2. 8. 1, 2, 3, 4, 5, 6, 7, 8 to neon. That's filled, right? Sulfur's in the third one. 1, 2. Watch this. 3, 4, 5, 6. It's got 6. Yeah? 2, 8, and then 6. 6 is what I'm looking at, right? So 6. 1, 2, 3, 4, 5, 6. Yes? Okay. 6 valence electrons. Aluminum. Again, if you're not sure, well, 2, 8, it's 13 protons, 13 electrons. 2, 8, and then 3. Yes? So, or count. 1, 2, 3. 1, 2, 3. That's a Lewis diagram. Okay? Only valence electrons. That's it. Now, I know what you're thinking. Mr. Bachek, the dog. That's the name. What happens if I get the potassium? Well, potassium's got 1. What about calcium? 2. What about scandium? How many does it have? Does it have 3? It does, kind of by fluke. Okay. Can I keep counting across after that? And the answer is no, you can't. All right. But I will show you how to get the number of valence electrons for those. Okay, we'll talk about that. Not quite yet, but we will talk about that. You're not going to have to worry about that for homework or anything. You might get the calcium, but it's 2, 8, 8, and then there's another 2. Okay. By the way, why are elements in groups? And this is tomorrow's lesson. Okay, riveting stuff. Why are these elements in groups? How did they come up with this? These all have 1 valence electron, yes? These all have 2. That's why they're in that group, okay? Because they all behave similarly, okay? We got a few minutes here, so here's your homework. So let's have this done for tomorrow. You're going to have to copy this down. Hopefully you can see that. And you can just kind of shorten this up a little bit here, but basically this one here is just protons, electrons, neutrons. So go ahead and copy those. And here's the numbers here. Remember, the numbers represent the what? Yeah. Yeah, take a picture. Yeah, take a picture if you want to last longer. Stupid technology. Oh, I shouldn't say that. Hey.